I am going to spend maximum $50. That's my goal. So let's figure it out what we have on that left side. So what I have is the book. I mean, the CD is the first. So, and I know that each CD is $5.25. So let's say CD is C. Let's assign a variable, and then book is B. So the money that I'm going to spend for CDs is $5.25 times C, because if I multiply the unit price with the number of items that I'm buying, I'm going to get how much money I spent for that item. Plus, I have the second item, which is a book, which is $3, so 3B. So I got my inequality. So with the fundamental theorem of algebra that you're going to learn in the future, if you would like to solve an equation or inequality, you have to have same number of equation and same number of variable. Okay, when I look at this inequality, I have two variables, C and B. But when I look at the inequality, I have just one inequality. So with the algebra, I cannot solve this one. So I need to have one more inequality, which I cannot have right now. So basically, I'm going to use trial and error, the possibilities, okay? So the possibilities. So what I can do is I can use the graphing calculator to solve it. I can use guess and check to solve it, and so on, okay? For example, I may work on the number, which is, I have 5.25. I try to get the whole number. So that's 0.25. If I multiply that one by 4, or the multiples of 4, I'm going to get the whole number, okay? Because quarter times 4 is 1. So I may use that one. For example, I may say I have 4 CDs. If I substitute 4 over here, I may figure out how many books I can buy, okay? So if I do that one, it's going to be $21, because 4 times 5, 25 is 21, plus 3B less than or equal to 50. As you see, I start with a default value. Let's say the number of CDs is 4, okay? Because I don't have the second inequality, so I'm going to use trial and error or graphing calculator. I'll tell you that one later on. So if I solve this inequality, right now I can solve this inequality because I have a single variable and one inequality. If I subtract 21 from both sides, so that gives us 3B less than or equal to 29. When I divide 3 both sides by 3 both sides, I'm going to see that B is less than or equal to 27 is 9 times, so 9 times 9.3, I think 9.3-ish. So that means I can buy 9 books and I have some left over, okay, because of that 0.3. That's the one option, one possibility, okay? Remember, while we're covering inequalities in Algebra 1, we learned that inequality's solution is a region. It's not a single value. It's a set of values. So let me show this one in a graphing calculator, but I'm going to use different variables because graphing calculator does not accept more x and other than x and y. So I'm just going to use x and y. So let me go and then have my graphing calculator to the screen. So let's use Desmos, which is the easiest one that I can use right now. So let's go Desmos on the other screen and then carry this one to our screen. All right, Desmos, start graphing. Instead of B and C, I'm going to use X and Y, okay? Because the calculator understands X and Y, that's why. That's the only 2 variables defined in this calculator. Otherwise, I need to define the variable and so on and so forth. So let's say I have 5.25. Instead of C, I'm going to use X number of CDs, let's say. Then plus, I have 3B. I'm going to use 3Y, okay? Y number of books is equal to 50. Not equal, sorry, less than or equal to. Less than or equal to. Actually, let me use the keyboard over here because I don't have a less than or equal to sign. And then 50. As you see, we got a shaded region. So let me zoom out so you can see that one clearly. So right now, what I see is any number on this shaded region for X and Y are possible solution set, okay? First of all, I'm talking about books and CDs. I need to focus on the first quadrant only, okay? Not the second quadrant, third quadrant, or fourth quadrant, because I have negative values on those three. In the real life, and I mean in this problem, I don't have negative number because I have positive number of books and positive number of CDs. So basically, I'm going to focus on this triangle over here, okay? Bounded with the x-axis, the y-axis, and the graph that I have. So whatever the number I pick, that's one possible answer for me. For example, this point over here, 5, 5. So that means if I buy 5 CDs and 5 books, I'm going to have some left over because my intersection is not this intersection that you see on the in front of the mouse, that is not on the line. Whenever the point that I'm pointing is not on the line, that means I have some left over. If I go the right side, the white side over here, unshaded side, that means I'm going to spend more money than $50, which I don't have. So I cannot pass this line. Whatever I'm going to do it on this line, okay? I'm on the left side of this line. So I have many solutions, like 1, 5, 1 CD, 5 books, or 10 books, 2 CDs, okay? Or 10 books, 3 CDs, and so on. But 10 books, 4 CDs, not possible because I'm passing the line, okay? Are we clear with this?
Yeah.
Okay, it's inequality. There is no one single answer. We have many answers, a set of answers, okay, many answers. But again, your answer must be in this triangle, okay? Your answer pair must be in this triangle, okay? All right, let's put this in a side. Here you go, got rid of. Let's get the key concept of today. So we're going to cover 2 variables inequality today. 2 variables inequality, which is the 8th lesson, I think, of the chapter. So our key concept saying that essential understanding, graphing an inequality in 2 variables is similar to graphing a line. Like I did it with the graphing calculator. We're going to use a graphing calculator mostly. We're not going to use paper pencil. The graph of a linear inequality contains all points on one side of the line and may or may not include the points on the line. So remember closed circle, open circle, we did before with the greater than, less than, those are open circle, less than or equal to, greater than or equal to, closed circle. So that in this case, those equal to's included so that we're gonna have a solid line. For greater than, less than, we're going to use dashed line, okay? Dotted line, or the other way to say dotted line, which is the point on the line is not included, okay? So we're going to focus on mainly linear inequality, which means the first degree functions. The x degree is 1, the y's degree is 1, both variables, degrees is 1. And then, as I said, we have boundary lines where the graph, where the function satisfies or not. So we have the boundaries. And then also we're going to use the key term half plane. The boundary separates the coordinate plane into 2 half planes, okay? One consists of the solution, one is does not consist of the solution. As you remember from the do now, the shaded region is 1 half, which is the solution side, and then unshaded side is the, which is not the solution side, okay? So we'll do practice on this one, how to determine, okay? Let's look at the first problem. So I'm not gonna start the core of the lesson right away. First, we're gonna focus on how to graph an inequality with 2 variables. If one variable is a straight line, the number line, it's easy. But in this case, we have two variables. If you have two variables, that means you're going to use coordinate plane, which means two number lines, one horizontal, one vertical. So problem one saying that graphing linear inequality, what is the graph of each inequality? I'm going to do a paper pencil, just one, okay, just one, but mostly I'm going to use the graphing calculator, okay? So let's say this is my coordinate plane, okay? If I would like to do, let's say, the x-axis and the y-axis, if I would like to graph this y greater than 3x minus 1, I'm going to use slope-intercept form. Remember, we discussed about that one, y is equal to mx plus b form. So in this case, my b is -1, so I'm going to go to -1, and then I'm going to mark that one first. First, I'm going to mark the y-intercept. Then I'm going to use the slope, the m, which is 3. 3 means, as a fraction, 3 means 3 over 1. So that means rise over run. Remember the slope. I'm going to rise 3, and then I'm going to go right or left, depends on positive and negative, 1 unit, okay? So let's rise 3 units, 1, 2, 3 units, so that's 2. And then we're going to run 1 unit because to the right because of positive slope. So let's say this is 1. So right there. So when I connect these two lines, okay, these two lines, I'm going to get my graph, but I'm not done yet. I made a mistake. I draw this straight line. I'm the solid line. That's a mistake because I don't know if it's a solid or not. So first I need to decide, is it solid or is it a dotted line? So in that case, I'm going to focus on inequality symbol. If I have greater than or less than, one of them, greater than or less than, then I have a dotted line, okay? Remember, greater than, less than is open circle, not included, same thing. Dotted line, the line is not included to the solution, okay? So I'm gonna connect the points with a dotted line. And then I'm gonna decide which side I'm gonna shade it, okay? Which side I'm gonna shade it. I have two options for you, two methods that you may use. Number one, but this is only works when the y by itself, okay, like this. When the y by itself, pay attention to the y-intercept, this red point, y-intercept. And then look at the inequality. It says y greater. So when I look at this point, above is greater than the below, because when I go up, I'm going to get positive results. When I go down on this line, I'm going to get always negative results. So that means above is greater. So my inequality says y greater, so that I'm going to shade it this line. Okay, so my solution is on the left side of the green line. The line is not included. Okay, this is one method. When the y by itself, go whatever it says in the inequality. It says y greater, go the greater side. If it's y is less, go the less side. The other method is the most common method. Most of the textbook use this one. Pick a point at any side. It doesn't matter, okay? For example, if I pick a point over here, let's say this point is 4, -2, okay? A random point at the random location, it doesn't matter. And then substitute this point in your inequality. If you got true statement, shade it the point side. If you got false statement, shade it the other side. So let's check. Y greater than 3x minus 1. I'm going to substitute those. Y is -2, x is 4, -2 greater than 12 minus 1, -2 is greater than 11, which is a false statement because negative number cannot be greater than positive number. So I'm going to shade it to the other side. As you see, I already shaded the other side, not the point side. So you have two options like this. I'm going to repeat this one in part B as well, okay? whichever is easy for you, pick that one and stick with that one. Don't go back and forth, okay? Stick one of them. This is the paper pencil, okay? Let me do graphing method. It's with the graphing calculator, it's gonna give you the answer right away, okay? It's nothing fancy. So let me write this inequality, y greater than 3x minus 1. When you use a graphing calculator, it's gonna give you right away. That's it, okay? As you see, already shaded. Already the line is dotted line. Everything. Here you go. Let's draw a coordinate plane, x and y. And then again, if the y not by itself like this, you must do that one first for the paper pencil and the TI-84 calculator. You must get the y by itself. So since the y by itself, I don't need to worry about it. I have -1 on the y-intercept. So -1, I'm gonna mark the y-intercept first. And then I'm gonna use the slope, which is 3/1. I'm gonna go 3 up, 1, 2, 3, let's say. So that's 2. And then 1 to the right, because of positive. If it's negative, I'm gonna go to the left. Okay, so that's 1. So, and then I'm gonna decide solid or the dotted line, which I have inequality symbol is less than or equal to. So I'm gonna use solid line in this case because equal to means included. So the line is included to solution. Then I'm gonna find the side that I'm gonna shade it to get the answer. As I said, I have two methods. Method number 1, just pay attention to the y-intercept, and then pay attention to y in your inequality. It says y less than or equal to. I know down is less on the y-axis, so I'm gonna shade it this side. This is easier. I don't need to do calculation like this one over here, okay? All right, but if you want to prefer do calculation, if the origin is not on the line, I'll give you a trick on that. If the origin is not on the line like this right here, origin 0, 0, because 0, 0 is easy to calculate, that's why. So use the origin 0, 0 and substitute in the inequality. 0 less than or equal to 3 times 0 minus 1. 0 is less than -1, which is a false statement again. Since it's a false statement, you're gonna shade it the other side, not the origin side. Okay, you're gonna shade it the other side, which I already shaded, okay? So this is one of the trick, the origin, okay? If you wanna use the point method, because it's easy to calculate, because zeros make our calculations easier, that's why. All right, I hope you guys, ladies, you understand this too. Do you have any question?
No. No.
I want to spend more time on this because this is a little bit tricky, that's why, okay? So let's look at the real life application of this kind of problem. So problems 2 says using a linear inequality entertainment application we have. The map shows the number of tickets needed for small or large rides at fair. So I have 2 categories. So I'm going to underline those, highlight those. Those are important. And you do not want to spend more than, okay, that's a nice term over here, more than $15 on tickets. So the maximum amount of money that you're going to spend is $15. That's your budget. How many small or large rides can you ride? Okay, I'm going to write the inequality by using 2 variables, let's say x and y. Okay, and then no more than is my inequality symbol, which is less than or equal to, whatever I'm going to do it less than or equal to 15. So I know that small rides contains 3 tickets, okay? Let's say x is the number of small rides, and y is the number of large rides, okay? So for the small rides, I need 3 tickets for the large rides, I need 5 tickets. And then each ticket is 25 cents. What I'm gonna do is, to make my life easier, I'm gonna calculate one small ride is how much. If I'm gonna have one small ride, that's 3 times 0.25, because 25 cents times 3, that gives us $0.75. And then for the large one, 5 times 0.25 is $1.25. I intentionally calculate these two numbers before writing my inequality, because I don't want to deal with the tickets and the tickets, because small rise is 3 tickets and I set X number of tickets. So both are the same thing, okay? So that means I'm going to use 3X and 5Y. Then I'm going to multiply with the number of tickets and so on and so forth. So it's going to be a little bit complicated. To eliminate that one, I figured out how much is this small right and how much is the large right by using information in the image. Okay, so right now, the total amount of money that I'm going to spend is maximum $15. So if I have X number of small rights, then I'm going to spend 0.75 times X much money, and then plus 1.25 times Y amount of money for the large one, okay? So right now, I have 2 options to solve this problem. Question says, how many small or large rights can you write? Number 1, I can use trial and error, okay? That works. That's totally fine. Just give a number to X and figure out the Y, okay? Let's say if this is 0.75, if I multiply this number by 4 times 0.75 is 3. So it's going to be, if I said if X is equal to 4, then 3 plus 1.25y less than or equal to 15. Subtract 3 from both sides, and then 12. And then divide both sides by 1.25. So let me do that one with my calculator. So 12 divided by 1.25, that gives us 9.6. So y is less than or equal to 9.6. So that means if I buy 4 small and 9 large rights, okay, then I have some money because of 9.6, okay? That 0.6 ticket is some money, that 0.6 times 0.25, because each ticket is 25 cents. So I'm gonna spend almost all of the money, okay? That's one possibility, okay? This is one possibility. If you would like to find more possibilities and in a short amount of time, the best way to do that one is a graphing calculator, okay? When you use a graphing calculator, it's easier. As I said, Desmos, you don't need to get the y by itself. 0.75 x plus 1.25 y, and then says less than or equal to, so here you go, and 15. Again, we are dealing with the positive numbers, number of rights, small and large. So I'm gonna just pay attention to this triangle over here, the first quadrant, okay? So for example, the one answer that I found, 4, 9. So 4 is right here, and then 9 is right here, as you see at this point. And this point is in the region that I shaded. So any point you can get it, for example, this one right here, okay? So that means 11 by 1, 2, 3. So that means you may have 11 small rights and 3 large rights. Or, for example, let's pick this one right here. You may buy 1 small and 2 large, and you have lots of money left, okay? Or what you can do is, as you see this point right here, because we have equal to, less than or equal to sign, You may buy 20 small rights, okay, and 0 large, and you're going to spend exactly $15, all of your money. Or the other one is you may get 0 small rights and 12 large rights, and you spend all of your money, and you just get one kind of rights, which is 12 large. And because the line, these 2 points are on the line. Any point that you pick on the line, that means you're spending all of your money. Okay, any point that on the left side of the line around this region, that means you are having some rights, and at the same time you have some left over from your budget. Okay, so are we clear with this, ladies?
Yeah.
Okay.
Yeah.
So without graphing calculator, can you do that? Because during the exam, you may not have the you may not have a chance to use a graphing calculator. That's why I tried to show you the both method. Okay.
I learned it last year.
Last year? Okay, perfect.
Mm-hmm.
Yes. So let's look at number 3, graphing an absolute value inequality. Okay, we covered the absolute value before, so let me get rid of this one. Absolute value inequality. Okay, so something is a little bit complex right now. I have more than one skills right now. I know how to deal with inequality. I know how to deal with absolute value, and I know how to deal with absolute value inequalities because I saw all of them. So right now, what I'm going to do is I am going to get the 2 inequalities because I have an absolute value inequality. So who's going to help me on this one? How I'm going to write those 2 inequalities? Or do I need those 2 inequalities to do this one? What do you think? Can we use parent function, the absolute value parent function, which is the absolute value of x?
Yeah.
Yeah, we can use that one. Right. So let me go to graphing calculator and then show you that one. So what I can do is I may get y by itself first. So let me do that. Let me get the y by itself. So when I get the y by itself, y is greater than absolute value of, just a second, greater than negative absolute value of x plus 2 plus 1. Did you understand what I did?
Yeah.
I skipped many steps. I just get the y by itself, okay? So right now, I'm going to use the parent function, the absolute value parent function, which is, let me go to the calculator and use that. I'm sorry. So remember our parent function was y is equal to the absolute value of x. I'm going to use equal to intentionally because I'm going to make a connection between our prior knowledge and this one. So right now I have inequality, okay? So let me use inequality in this case with the parent function. Y is greater than in my question. So I'll go greater than an absolute value of, I'm going to use the parent function again to see what kind of graph I'm going to get, okay? So right now, when I hide this is my absolute value function, the absolute value parent function with equation. But when I come to the inequality, I have a shaded region because inequality's solution is a shaded region, not the line. So let's get rid of this one. And let's build our question's answer on this one. So my inequality is negative absolute value of x plus 2 plus 1. So first of all, let's add that plus 2 inside it. Remember, whenever I add something inside it, which is I'm adding or subtracting to the x, something gonna happen left or right. Did you see that?
Yes.
Let me fix this one with the x greater than. Okay, so let's compare those two. The parent function is vertex is in the origin, and the next one, the plus 2, what happened? It's translate, I'm sorry, not rotate, it's translate our graph to the left. How many units? 2 units, because we had 2. So, and then we're gonna add 1 to outside, okay, which means we're gonna move up. Here you go. As you see, first we move to the left 2 units, and then we move to 1 unit up. Then we have something in front of the absolute value, which is a negative. So when I do this, what's gonna happen? When I put a negative in front of the absolute value, what's gonna happen to our graph? What's gonna happen to this? Anyone have any idea? Let's check then. Here you go. It's gonna go upside down, okay? It's gonna go upside down, and then shaded region is gonna change as well, okay? Shaded region is gonna change as well. So that means my answer is gonna be this one, okay? This one. Any value inside this shaded region is my answer for this problem. For example, 0, 0. For example, 5, 5, or 5, 4, or negative 5, negative 15, comma 5, for example, and so on, okay? So basically, ladies, you're gonna use just the parent function and then build on top of that, get your graph, then decide. It says y greater. Look at the intersection over here, the y-intercept. Is this side is greater or this side is greater at this point? Above or below is greater? When you look at the y-axis, at this point, I'm at this point, the y-intercept. Above is greater, so that means I'm gonna shade it this side, okay? That's why. Or just pick a point and substitute like 0, 0. When you substitute 0, 0 is greater than 0 plus 2, absolute value of 0 plus 2 is 2, but there's a negative in front of that, so it's gonna be negative 2. Plus 1 is negative 1, so 0 is greater than negative 1. So yes, so I'm gonna shade it the point side, this the point that I picked, okay? So this is our graph for this problem. Any question?
No.
Okay.
No.
I'm sorry, yeah, go ahead, please.
No, I don't have a question.
How about this problem, writing an inequality based on a graph? Again, you need to know transformation very well to do this one. That's why I covered the transformation with the absolute value before this. So let's look at this one. First of all, when I look at the line, line is dotted line. So dotted line means I have equal, not equal, sorry, greater than or less than. I'm gonna use one of this, greater than, less than, or greater than. I know one of this. Then I'm gonna look at this y-axis, y-intercept. When I look at the y-intercept, above is shaded, this side is shaded. The greater side is shaded because this side is greater at this point, this side is less. So that means I'm gonna use greater than sign, okay? So I figured out the inequality symbol. So, and then let's figure out the rule that we have. So if this is a parent function, that must be run over here like this. So on. So there's a translation on this one. The combination of two, because I am on the southeast. okay, of the graph. So that means I have a combination of those two, vertical and horizontal translation. So as you see, I move 2 units down, and then 2 units down, subtract 2, and then 1, 2, 3 units right, which is subtract 3. So that means I have absolute value of x, absolute value of x. If I move 3 units to the right, so I'm going to subtract 3 from this. And if I move 2 units down, then I'm going to subtract 2 from everything. And then I need to pay attention to slope. So let's get the slope of the point at the vertex. So when I look over here, let me pick 2 points. Let's pick those 2 points. So 1 by 1. I know in the parent function, I have 1 by 1 as well. So that means slope is not changing. So I don't need to put any number over here. Okay? I don't need to put any number over here. Also, the graph is upwards. So I don't need to use a reflection as well. So that means I am done with my inequality. So I'm just going to put a y over here. So y is greater than absolute value of x minus 3 and minus 2. So let's check our answer. Is that true or false? So let's go over here. We said y greater than absolute value of x minus 3, and then outside of that, minus 2. Yes, as you see, we move 2 units down, 3 units right, and its diagonal is 1 by 1, as you see, okay?